First order linear differential equations, part 2. In this part, we're going to look at a couple examples where we solve first order linear differential equations, which are of the form dy dx plus p of xy equals q of x. To solve this, we need an integrating factor, which is e to the integral of p of x dx. Let's look at our first example, which is dy dx equals 6x squared minus 3x squared y. Before I find the integrating factor, I'm going to put it in the standard form above, which is dy dx plus 3x squared y equals 6x squared. I can see my p of x now, which is 3x squared, and my integrating factor is e to the integral of p of x dx, or e to the integral of 3x squared dx. And the integral of 3x squared is x cubed. We don't need the plus c, which gives us the integrating factor of e to the x cubed. We will multiply that by each term in our differential equation over here. So we have dy dx times e to the x cubed plus 3x squared times e to the x cubed y equals 6x squared times e to the x cubed. Notice that the left side is going to be the derivative of y times the integrating factor. Take a little time to convince yourself that the derivative of that product goes back to where we started there. And the right side remains 6x squared times e to the x cubed. We can multiply both sides by dx, giving us d of y times e to the x cubed equals 6x squared times e to the x cubed times dx. And we can integrate both sides. Recall that the integral of d something is that something. We'll worry about the plus c later. So the left side gives us e to the x cubed times y. And the right side is a u sub. I'll do just a little of the work over here. U is x cubed. du is 3x squared dx. So I could rewrite the right side as 2 times e to the u du, which is 2 times e to the u, where u is x cubed, and here I will put the plus c. One more step. We need to get the y alone, so we'll divide both sides by e to the x cubed, or multiply both sides by e to the negative x cubed, which gives us y equals 2 plus ce to the negative x cubed. One more example. Let's consider the differential equation x times y prime minus y equals x squared. Now we wanted the form dy dx, which I'll write as y prime here, plus p of xy equals q of x. So it looks like we need to divide everything by x, which will give me y prime, or dy dx, minus 1 over x times y equals x. My p of x is negative 1 over x. The integrating factor, e to the integral of p of x, is e to the integral of negative 1 over x dx, which is e to the negative natural log of x. I'll leave off the absolute values here, as well as the plus c. Now I can't quite cancel the e in the natural log, because I have to have e to the natural log of something, but that's the natural log of x to the negative 1. So I just moved this up here to make it to the negative 1 power, and then rewrote it as 1 over x. And e to the natural log of 1 over x is 1 over x. So this is my integrating factor. So I can rewrite my differential equation, multiplying everything by 1 over x. I get y prime times 1 over x minus 1 over x times 1 over x times y equals x times 1 over x, or 1. The left side is the derivative of y times my integrating factor. Convince yourself that is true. And the right side remains. We can multiply both sides by dx, giving us d of y times 1 over x equals dx. And then integrating both sides, we get y times 1 over x equals x plus c. One last step, get our y alone. We'll multiply both sides by x, giving us y equals x squared plus c times x.